Hello and welcome to HP Gaming Garage. I am Professor Raja Ravichandra Prasad, Game Director at Artemisia College of Art and Design. The 14th module of game programming is 3D animation for games. 3D animation for games involves creating and managing animated characters and objects and integrating them into game engines to create immersive and responsive game experiences. Maya is a go-to 3D modeling and animation tool for game developers, and in the last module we have discussed how to use Maya. In this module we will be discussing different character types that can be created in Maya. To explain this in detail, I have Shriyams who will walk you through the module.
Thank you, Professor. Hello everyone, I am Shreyams and we will be discussing the module 3D Animation for Games curated by Professor Raja. Let's start by discussing the different types of characters which can be made in 3D tools such as Maya. These are the characters controlled by the player in the game. They are often the main character or protagonist of the game and are designed to be appealing and relatable to the player. Vehicles such as cars, planes and spaceships are often used in games to provide the player with a means of transportation or to enhance gameplay. Non-player characters are characters that are controlled by the game's AI and interact with the player or other characters in the game. NPCs can be designed to have different personalities and behaviors and can be created in Maya using a range of tools such as rigging and animation. Opponents are characters that the player must fight or defeat in the game. They are often designed to be challenging and have unique abilities and behaviors. Opponents can be created in Maya and then imported into the game engine along with their animations and AI behavior. Creatures and monsters are often found in fantasy or science fiction games and are designed to be unique and visually appealing. They can be created in Maya using tools such as sculpting and rigging and then imported into the game engine. Vehicles such as cars, planes and spaceships are often used in games to provide the player with a means of transportation or to enhance gameplay. These vehicles can be created in Maya and then imported into the game engine along with their animations and physics. Let's have a recap of what we discussed. Maya is a widely used 3D modeling and animation tool in game development. Different character types can be created in Maya for use in games. Player characters are controlled by the player and are designed to be relatable and appealing. Non-player characters, also known as NPCs, are controlled by game AI and can have unique personalities and behaviors. Opponents are characters that the player must fight or defeat, designed to be challenging with unique abilities and behaviors. Creatures and monsters are visually appealing and can be created in Maya using sculpting and rigging tools. Vehicles like cars, planes and spaceships can also be created in Maya for transportation and enhancing gameplay. Let's move on to discuss the process of rigging, skinning and animation and importing them into the game engine. Rigging a character is one of the most important steps in creating a 3D character for games or animations. This process involves creating a digital skeleton or structure that can be used to move and control the character's movements and actions. It includes a series of steps which the developer needs to follow. The first step in rigging a character is to create a skeleton of joints that will act as the character's bones. These joints are placed in strategic positions following the character's anatomy and will be used to control the movements of the character. Once the joints are in place, the next step is to bind the character's mesh or skin to the joints. This process involves creating a relationship between the joints and the character's geometry, allowing the mesh to move and deform with the joints. Weighting is the process of assigning different levels of influence to each joint on the character's mesh. This ensures that when a joint moves, only the part of the mesh associated with the joint move as well. This process is done to achieve a realistic deformation of the character's skin when it moves. After the weighting is complete, the next step is to create controls that will allow animators to move the character. These controls can take the form of buttons, sliders, or other user-friendly tools that enable animators to pose and animate the character quickly and easily. Once the rig is complete, it is crucial to test and refine the rig to ensure that it functions correctly and realistically. This process involves testing the rig's movement, checking for any errors or deformations, and making adjustments as necessary. Skinning is a vital process that attaches the 3D mesh or skin of a character to the digital skeleton created during the rigging process in Maya. With skinning, the developer can achieve realistic movements and bring your characters to life. Here are the steps involved in skinning a character. Firstly, the skin must be bound to the digital skeleton created during rigging. This process involves assigning the vertices of the mesh to specific joints in the skeleton. Next, it's time to adjust the weights of each vertex to ensure that they move correctly when the skeleton is animated. This process involves painting weights on each vertex, indicating how much influence each joint has on the specific area of the mesh. After adjusting the weights, the skinning must be tested and refined as necessary. This process involves animating the character and checking for any deformations or errors in the mesh's movement. Any issues can be addressed by adjusting the weights or making other adjustments to the skinning. Finally, the skinning can be fine-tuned by adjusting the weights and making additional refinements to ensure that the character's movements look realistic and natural. By following these steps, the developer can achieve natural and lifelike movements for your 3D characters, making them stand out in your game or animation project. Animating a character is the process of bringing it to life, making it believable and engaging. As an animator, one will have the power to create a character that moves with purpose, fluidity, and emotion. Here are the steps involved in the animation process. Keyframes are the foundation of animation. They represent the character's poses or positions at specific points in time. Setting keyframes is a critical step in creating an animation that flows naturally and looks realistic. Maya offers a variety of tools to help you set keyframes, including motion capture technology. Refining the motion is where the magic happens. This step involves adjusting the timing and spacing of the keyframes to create smooth and natural looking movement. By adjusting the ease in and out of each keyframe and the curve of the motion, you can create a convincing performance that draws the audience in. Secondary motion adds realism and depth to your character's movements. It includes things like characters' hair and clothing movement in response to their actions or their subtle movements of their body as they perform an action. Adding secondary motion manually or using tools like dynamic simulations can create an animation that looks natural and organic. The final step is to polish the animation by adding small details that make a big difference. Fine-tuning the facial expressions, body language and movements can help convey the character's emotions and personality, making them more relatable and engaging. With these steps, you can create animations that capture the imagination of your audience and breathe life into your characters. The process of importing rigged, skinned and animated characters from Maya into a game engine is an essential step, but it doesn't have to be intimidating. Let's break it down into simple, manageable steps. The first step is to export the rigged character from Maya in a format that can be read by the game engine. This can be done using common formats such as FBX, Collada or Albemic. Ensure that the exported file includes the rig, skin and any animation data that will be used in the game. Next, import the file into the game engine. Although the process of importing the file may differ based on the game engine you're using, it usually involves selecting the file and specifying import settings. Once the game engine imports the file, it will create a representation of the character that can be used in the game. After importing the character into the game engine, assign any materials and textures to the character's mesh. This involves mapping textures and materials to the character's UVs and ensuring that they are correctly aligned. Ensure that the rig functions correctly in the game engine by testing the character's movements and checking for any errors or deformations in the mesh. If the character has animation data, import it into the game engine. This process is similar to importing the rig and involves selecting the file and specifying import settings. Implement the animation data into the game by creating animation triggers in the game and assigning the appropriate animations to each trigger. The final step is to fine-tune the character by adjusting the rig, skinning and animations as necessary to ensure that it functions correctly in the game and looks and feels as intended. Let's recap what we discussed. Rigging a character in Maya. Create joints that act as the character's bones. Bind the character's mesh or skin to the joints. Assign different levels of influence to each joint on the character's mesh. Create controls that allows animators to move the character. Test and refine the rig to ensure that it functions correctly and realistically. Skinning a character in Maya. Bind the skin to the digital skeleton created during rigging. Adjust the weights of each vertex to ensure that they move correctly when the skeleton is animated. Test the skinning and refine it as necessary. Fine-tune the skinning to ensure that the character's movements look realistic and natural. Animating a character in Maya. Set keyframes that represent the character's pose or position. Refine the motion by adjusting the timing and spacing of the keyframes. Add secondary motion that occurs naturally as a result of the character's primary motion. Polish the animation by adding small details and refining the motion. Importing a character from Maya into a game engine. Export the rigged character in a format that can be read by the game engine. Import the file into the game engine. Assign materials and textures to the character's mesh. Test the rig to ensure that it functions correctly in the game engine. Import any animation data into the game engine. Let's move on to discuss the next topic on how animations are created and managed in games. Masking is a technique that allows the developer to selectively show or hide parts of an animation. This can add a layer of complexity and depth to the game by enabling you to create dynamic animations for your characters and objects. With masking, one can easily obscure parts of the animation, like when a character is wearing a mask or an object is particularly obstructed. Layering is another powerful technique that allows the developer to combine multiple animations to create complex and dynamic movements for the game characters. For instance, a character may have separate animations for walking, running, jumping and attacking, and by layering these animations together, you can create seamless movements that combine different animations. So, whether one wants to add complexity and depth to your animations or create more dynamic and responsive game characters, masking and layering are techniques that you need. By mastering these techniques, you can create stunning game animations that will captivate your players and keep them coming back for more. In game development, it is often beneficial to reuse animations for multiple models. This means that the same animation data is used to animate different models in the game, rather than creating new animations for each model. There are several advantages to using the same animations for multiple models. First, it can save time and resources by reducing the amount of animation work required for each model. Instead of creating new animations for each model, developers can reuse existing animations, which can significantly reduce the workload and development time. Second, reusing animations can help to ensure consistency across different models. If all models in the game use the same animation data, they will all move and behave in a consistent manner. This can help to create a cohesive game experience where all elements of the game feel like they belong together. To use the same animations for multiple models, game developers must ensure that the models are compatible with the animation data. This typically involves using same rigging and skeletal structures for each model, as well as ensuring that the animations are properly scaled and oriented to match the models. In some cases, developers may need to make minor adjustments to the animation data to ensure that it works properly with each model. For example, they may need to adjust the timing or positioning of certain keyframes to ensure that the animation looks natural and fits well with the model. Let's recap what we discussed. Animation in games are created using 3D modeling and animation software managed using an animation system that blends between different animations to create smooth transitions. Animations are organized into animation clips, which are collections of keyframes that represent a specific animation sequence. The animation system may also handle other aspects of character motion such as IK, physics simulations, and ragdoll physics. Masking and layering of animations are two common techniques used in game engines to create more complex and dynamic animations. Masking selectively shows or hides parts of an animation, while layering involves combining multiple animations to create a more complex and dynamic animation sequence. Game developers use animation blending or additive animation to layer multiple animations in game engines. Reusing animations for multiple models can save time and resources by reducing the amount of animation work required for each model. This can help ensure consistency, and developers must ensure that the models are compatible with the animation data. In some cases, developers may need to make minor adjustments to the animation data to ensure that it works properly with each model.
Thank you, Shriyams, for the detailed walkthrough of the module. With this, we have come to the end of the module and I hope you enjoyed it. Stay tuned for your HP Learning Assessment so that you can be certified and start your career in game development. Thank you for joining us.